Welcome back to the BLocIoT. In one of the previous videos, we showed you how you can use MQTT protocol in Siemens S7-1200 and S7-1500 PLCs. We walk you through all the steps, including importing the LMQTT library, programming the PLCs, and we showed you the results on real hardware, as you can see on the screen, to transfer the PLC data to MQTT broker, which is installed on a Raspberry Pi 5. In this tutorial video, we are going to take another step forward to use OPC UA PubSub over MQTT to transfer our PLC data to an MQTT broker, and we will subscribe to that data that has been published from PLC 1 and PLC 2. Also, we are going to subscribe to the data from a Python application to visualize some of the data that has been published to the MQTT broker. We will not discuss the details of MQTT or OPC UA PubSub over MQTT in this video, so I will just focus on the technical aspect, and I'm going to make this video a tutorial to show you how you can implement OPC UA PubSub on your Siemens PLCs. We can make another video to go over the details of advantages or disadvantages of OPC UA PubSub over MQTT, but in this video, let's be focused on implementing this feature on Siemens PLCs. So without further ado, let's jump into the details. So if you remember from the previous video, to use the MQTT on Siemens PLCs, you will need to download a library from Siemens website free of charge. There is no extra license to your TI portal or on your PLC side to use this feature. So for today's video, which is OPC UA PubSub over MQTT, you can go over to the same website and download the library from this website. And we are going to use this library throughout this tutorial. Again, Siemens has all these libraries for different applications. For example, there is a library for HTTP communication or just MQTT that we saw in the last video. Or if you need the SNMP communication for different applications, there is a library for that. So once you downloaded the documentation for these libraries and also the library itself for the version of the TI portal that you are using, I can import the version 19 to my TI portal version 20 without any problem. It is very important to download the documentation also because it has all the information that you need to use all these libraries. And I walked you through the LMQTT library before, but today let's focus on the LOPC UA, which is the library for implementing the OPC UA PubSub in TI portal. As you can see, there are two sets of libraries or function blocks for implementing OPC UA PubSub via UDP or MQTT. As you may know, one of the advantages of OPC UA PubSub over other standards such as MQTT Sparkplug B is that OPC UA PubSub can be used over MQTT, UDP, or other transfer protocols, and it's not tied just to MQTT. In this video, we are going to use OPC UA PubSub via MQTT, so I can read through all the information on this documentation for the OPC UA PubSub via MQTT. As you can see, this is the idea that we are going to follow along and implement in our project. So I have a PLC, which is S7-1500. It could be a S7-1200 as well. As you may know, these two PLCs are interchangeable, and S7-1500 is a more advanced version of the 1200. And on the middle, I have an MQTT broker, which in my case is running on a Raspberry Pi. You may be running your MQTT broker on the cloud or anywhere else, perhaps on a server running on your enterprise network or OT network. It really does not matter. All we care is the MQTT broker that is accessible to the PLC. And using this library, we can publish our data to the MQTT broker. Any other PLC or device or software application can subscribe to this data and use it in different applications. For example, for data visualization, for AI and ML applications, and you name it. I don't want to spend time on the details of OPC UA PubSub and explain you what are different terms such as writer group, reader group, dataset writer, and so on, because there are plenty of information available on the web about the OPC UA PubSub that you can refer to. But just for your information, this document also includes all those principles that you need about OPC UA PubSub, and you can quickly go over them. Similar to what we did to LMQTT library, you can start importing your library to your TI portal and start using it in your program. But the good news is there are a couple of good application examples available on Siemens Industry Online Support website that you can take advantage of. Basically, you can download this example or sample applications and try them out by yourself. And of course, you need to customize the code and change them as you would. And that's what I'm going to do today as well. I'm going to use this application example, which is OPC UA PubSub with S7-1500 based on MQTT JSON. So in this application, this is what we are going to work on. We have two PLCs. Both of them are S7-1500 PLCs. Again, they could be S7-1200 as well. One PLC acts as a publisher of the data, and it publishes some information or data from the PLC data block to an MQTT broker. And there is another PLC in our configuration, which is a subscriber to the data that is available on the MQTT broker. I've also added a simple Python application that subscribes to the same data and visualizes one of the data points on a graph. So if you don't want to spend much time to import the libraries and do a quick programming to use this library, you may download this application example from this link. Okay, now let's jump into the TI portal and do the programming, do the tests, and see the results in real life. Okay, here we are back to TI portal. As I mentioned, I'm using TI portal version 20, but really it doesn't matter as long as your TI portal is not too old. You can still take advantage of LMQTT and overall different libraries from Siemens in your PLCs. So here is the overview of my TI portal. As you can see, I have two PLCs in my project. One is the Publisher PLC and the other one is a PLC which acts as a subscriber. Again, I could have hundreds of PLCs as publisher or as a subscriber. It really does not matter. The same principle applies to larger scale systems as well. And on the right side, under the libraries, as you can see, I have the LMQTT library and LOPC UA library in my project. My Publisher PLC is a 1513-1 PN PLC and subscriber is 1516-3 PN PLC. Because I don't have two S7-1500 PLCs to test, I'm going to take advantages of PLC simulation in the Siemens platform. So I'm just going to use S7 PLC Advanced, which is one of my favorite software from Siemens because it lets you create virtual PLCs for simulation, and they are not just a simulation to test your logic. They can actually connect to different devices over the network. So as you can see, my PLC Sim Advanced is connected to the local area network on port 1, and I have two PLCs with different IP addresses and they are ready to be used. I can download to them like a real PLC and connect to my MQTT broker or my SCADA or HMI software on a separate PC. So now we can just minimize the PLC Sim Advanced. Now let's look into the details of our program and see how it works and how you can customize it for your own application. The first PLC, which is the Publisher, I'm just going to open it and I'm going to Program Blocks. And as you can see, I have a few data blocks, one function and one cyclic interrupt to run my OPC UA PubSub function block and also some simulation logic. So if you open this organization block, you will have two networks. On the first network, which runs the FC14, which is the process simulation, it just generates some data to be published to the MQTT broker on these tags. I've also added a new tag to the enable because I wanted to have control over the process simulation to start it or stop it. On the second network, you have LOPC UA Pub MQTT JSON function block. So this function block is the core for using OPC UA PubSub in Siemens PLCs. As you can see, it's fairly simple and compact, using one function block and defining some tag for input and output. Your PLC can publish the data using the OPC UA PubSub standard to MQTT broker or another PLC. We have two main data blocks in our project. One of the data block is associated with the configuration of this function block, such as the connection properties, We will walk you through that, and also another data block for which includes the data that is going to be published to the MQTT broker. So the first one is controlling pub MQTT. This is where you define your connection parameters, such as the IP address for the broker, if you have a TLS or certificate to secure the communication, if you want to enable the keep alive bits, or the most important parameters is MQTT topic, that the PLC will publish the data to that topic. So in my case, I'm going to publish my data to a topic called PLC1. If your MQTT broker has a username and password, you need to specify it here, and you can give your PLC a custom client identifier. In my case, I'm just using PLC1, and of course you need to specify the IP address of your MQTT broker and the port that your MQTT broker is running on. And there are other parameters that you might need to customize based on your application. But as I mentioned, the most important parameters are IP address for your MQTT broker, the port, the username and password, MQTT topic, the client ID for your PLC, and the keep alive bits in case you want to use this keep alive feature of the MQTT, and so on. The second data block includes the data that we are interested to publish to the MQTT broker. As you can see, I have this published data set, which is an array of 6, and on each of these I have different data fields, and under each data field I have a value, and so on. So again, you can customize all these data, but the whole idea of using OPC UA PubSub is using the standard data format, so everyone else also can use it without contacting you to know, okay, what's your data format? If you use this standard format or PLC data type, the second PLC or another software application, they can also know what's the format that the data is being published to. And the beauty of using these libraries from Siemens is you don't need to create all these PLC data types. They are already created for you, and you can just grab them and use them. Okay, so we have these two data block, and we have this function for process simulation. Again, of course, this is just for simulation. As you can see, it's just incrementing or adding 1, 2, or another number, which we are going to publish to the MQTT broker. But of course, in a real life, these are real process values that you are going to publish. Okay, that's really it for the Publisher PLC. And as you can see on the subscriber, you have almost the same thing. Of course, you don't have any process simulation because you're just subscribing to some data and you're going to save them in another data block, which is the same and is called data sub MQTT. So if you look into the program on the main organization block, you only have one simple function block, which is LOPCUA sub MQTT JSON. Again, here, all I need to do is going to the connection parameter. I need to define my MQTT connection parameter, which are the address or IP address for the broker, the port, which topic I'm going to subscribe to, if there is any username and password, and again, if the keep alive bit is on or not. I'm going to close this window. Now is the time I can just download to the both PLCs and see the result. So at first, I'm going to download to my Publisher PLC. All I need to do, I select my PLC and I hit the download. Once the Publisher PLC is downloaded too, you can download to the Subscriber PLC as well. Now the program is transferred to both PLCs. Let's go online with both of them. Alright, as you can see, both PLCs are online with no error. And now I can go to the Publisher PLC and open the cyclic interrupt, and let's just monitor it. Okay, let's first enable or change the value of the tag start to 1. And as you can see, these values are changing. These are the process simulation again. The first value is just a Boolean value, which is, it can be false or true. And there are other variables which are just integers. And the last value is a string value, which just changes between hello world and goodbye world. So now all we need to do, we just need to enable this block, and at that point the PLC will start publishing the data to the MQTT broker. After enabling the block, you always need to watch out the error status. If it's true, that means there has been some error, and normally this happens if there is any problem connecting your PLC to the MQTT broker. And the nice thing about this block is you can just check the status code and you can refer to the manual and find out what's the problem. So it looks like there has been no error in my function, and now if I go and check my MQTT broker, I should have received all this data in real time. So I'm just going to use the MQTT-X as MQTT client. You may use other MQTT client software such as MQTT Explorer or your favorite MQTT client application. So now I'm just going to connect to my MQTT broker using this software, and once I hit the connect, and I have already subscribed to PLC 1 topic, and as you can see, all the data are coming to my PLC. So now we can just close the project for the PLC publisher, because really that's all we need to care about. We just enable this block and it just streams the data or publishes the values upon any change. So it's very important to know this is event driven. It doesn't stream the data in a time manner. The reason I'm just getting these values in MQTT broker over the time, because I'm generating these values in a predefined time. If I just disable this and I change any value, I will only get the results in the MQTT broker after every change. That's the whole idea behind OPC UA PubSub, because it's not like a traditional OPC UA which works based on the server and client mechanism or architecture, where the client constantly pulls the data from the server, and it's not really efficient in a large scale applications and any IIoT system, which we may deal with thousands or millions of devices. So now let's go to our subscriber PLC. We can just go online with it again. And there is also a watch table that is already created for you, so you can monitor the values that are receiving from the MQTT broker. So as you can see here, I don't get any value because the subscriber function block is not enabled yet. So to do that, I'm just going under the program blocks and I'm going to the main, and let's go online with it. And I'm just going to modify the enable to 1. Again, I'm watching here, there is no error. The status code 7006 is connected to the broker, which is good. And now if we go to the watch table of my subscriber PLC, we can see that all the data are coming. And of course, the data is being streamed or published to the MQTT broker at the same time as well. And of course, on the Publisher PLC, if we just disable this block, no data will be published to the MQTT broker. And as you can see, no new data is being published to the MQTT broker. And of course, on the subscriber PLC, there is no data coming. So again, this is the most important aspect for any event-driven architecture, because it saves you a lot of bandwidth and of course the data transmission cost, because you don't want to constantly pull the data. And that's why you always want to have event-driven architecture in any IIoT system. So let's just enable the block again. Now the data is being published to the MQTT broker again. And if I go back to the subscriber, the changes are visible here. As you saw, using just one single function block, I was able to use OPC UA PubSub on my Siemens PLC. And from now on, any other application or devices can subscribe to this data and they can communicate with each other over MQTT or UDP. But just to demonstrate more features, here I have a simple Python application that basically subscribes to the PLC 1 and extracts one of the values that are being published to. As you can see, I'm publishing several values, and of course I'm subscribing to several values as well: Boolean, integer 16 and integer 32 bits and so on. But in my Python project, I'm just subscribing to one of these values, which I believe is this one. We will double check. So let's go to my Python code. I'm just going to run it. As you can see, the value is being extracted and the JSON string is being parsed, and I get the value on my terminal. And I also have this simple graph that visualizes the data that has been received from the MQTT broker. So this is the value that is being used in my Python code. Sorry, this one. So basically I'm subscribing to this value, and this is the tag on my PLC. So that is pretty much it. And as you saw, it's very easy to use MQTT and of course OPC UA PubSub standard on your Siemens PLCs using a couple of function blocks that Siemens gives you free of charge. From what I know, the only other PLC that supports OPC UA PubSub are those PLCs that are based on codices. Again, I'm not familiar with all the PLCs in the market, and I'm very curious to know what other PLCs support OPC UA PubSub. So now you have enough knowledge to use OPC UA PubSub on your Siemens PLCs on your IIoT project. So imagine you are working on a plant where all the devices and applications, they understand OPC UA PubSub. Using this feature, they can all talk to each other, and each node can publish or subscribe to different information on a MQTT broker, and that's how easy it is. I don't know what you want to name this architecture, but I personally try to stay away from buzzwords and inventing or creating new concept and terminology. This is what I call event-driven architecture based on MQTT and OPC UA. I don't want to make this video longer. We are going to have more videos in the future about the same topic. And if you like this video, please share it with your network and friends, and give it a like, and support us by subscribing to the BLocIoT YouTube channel and LinkedIn page. It doesn't cost you anything, but it will help us a lot to keep moving. Until the next time, have a great day or night, and thanks again for watching and your time.
It's not a game, it's a rich thing.